you all for coming. This is Understanding Elixir's Recompilation. My name is Ranelli. This is my third time here at ElixirConf, and I'm from São Paulo, Brazil. If you haven't already guessed by my weird accent. I started working with Elixir at Sherpa in 2015. Sherpa is a Brazilian startup, and I spoke about it at ElixirConf twice. I'm an organizer of the Elixir São Paulo meetup. We are probably the biggest meetup in Brazil, and maybe even the biggest meetup in the Southern Hemisphere. We've got like 700 people in our Telegram group. Before working with Elixir, I did lots of Ruby, Python, C#, and other stuff like Fortran, MATLAB. Yeah. And today I'm an Elixir engineer at Telnix. Telnix is a Chicago-based company, and I work remotely from Brazil. And I'll talk a little bit about Telnix. You probably have heard about Telnix already because we are on your lanyards. And yeah, Telnix is a global communications company. We provide communication services like VoIP, messaging, SMS, and that kind of stuff. And we've got a global network. All of the green dots are places that we already have presence. So you can make a telephone call in Vancouver and it would terminate like in Sydney, and it all happens inside of our private network that contributes to less latency and lots of stuff. We're a bottom-up company. We began building our telephony infrastructure, our telephony engine, and now we're building applications and more stuff on top of that. And the blue dots are the places where we plan to have a point of presence in the future, hopefully next year. And we're sponsoring ElixirConf. We've got 12 Elixir engineers here at the conference. They're all sitting over there to make me feel pressured. And yeah, that's it for Telnix. And let's talk about Elixir's recompilation. Now, this is like a weird topic. I haven't seen many people talking about it. And the first question that we always should ask them is, why should you care about this kind of stuff? Why should you care about something? Why should I spend 40 minutes listening to someone describe this? So I'll show you something. I have here a huge project, and this is recompile. And I'll just do something that we do every time. I'll just touch a view file, like imagine that you're adding a new field or correcting a typo or whatever. And now I'm going to compile the project again. And I now face this situation. I'm compiling 606 files because I changed the view. And as you can see, this is taking a while. This is taking some time. Now imagine that you have to wait for this time. Every time you want to run your tests or you do any change in your project. And yes, it is as horrible as you can imagine. Maybe even worse. And I encountered this problem. I first faced this problem in Elixir 1.2. I hinted about this problem in my last year's talk on Phoenix, which I described how we had like a very big Phoenix project. And at that time, no tooling that I'm going to show you today was available. No one really knew what caused this problem, and I asked help from Jose himself because we were all going crazy at our team because anything that we did would take like 3-4 minutes to compile, and the times were getting larger and larger, and we got really desperate. So we started to dig into this problem, and I'm going to describe what this problem is, why it happens, what the core team and the library authors have worked on to mitigate this problem, and hopefully you won't have to suffer as we did. And now let's think about why does recompilation happen? Why do we need to recompile stuff? And the answer is metaprogramming. The main feature, in my opinion, that sets Elixir and Erlang apart lots of cool stuff and cool libraries, and our life is more joyful because we do have metaprogramming. But it has its costs, and I'm going to show an example on why this needs to happen. So I have here a very simple project, and I have this module called Metaprogramming that defines a macro that does something super fancy. And there's this other module, the Metaprogramming module, that requires the Metaprogramming module because you need to require to invoke a macro, and that's it, right? And I'm going to run this on IEX to simulate the scenario where recompilation doesn't happen. So I have the meta-programmed module, and I'll call some function. This is super fancy. And I'll require the meta-programming module, and run the same macro. You can see that the values are in sync.
No, I forgot to put it on.
Now I'm going to change the macro definition to something super fancy. And I'll reload the metaprogramming module. So this simulates the recompilation of that module. And you can see that now the files are out of sync. Like when I read the code and I evaluate the code, it doesn't make any sense. What needs to happen is we need to recompile the metaprogrammed module. And if I do that, then they are back in sync again. And this kind of job is done to us by the compiler. And that's why this thing needs to happen. If you're using some module to inject code in another module, if the module that is injecting code changes, you need to recompile all the modules that are injected by it, right? That's why we need recompilation to happen. And right, so how do we find out what is recompiling? This is if you're facing a problem like the one I showed in the beginning, how do you find out which are those 606 files? How do you find out what is being recompiled? And at the time that we started facing this problem, this was all we have, all we had. iNotify-Wait is a tool in Linux distributions that allow you to monitor the file system and get messages and to see what files have changed. And that's actually what Phoenix uses under the hood to do hot code reloads, like automatic code reloads. And how does it work? I have a very simple example here. I have, I'll run iNotify-Wait, E, modify on the stuff directory. And this blocks the foreground, so I'll take it to the background. And if I change something inside the stuff directory, you can get this like modify, right? So if some file changes in that directory, you are able to find out what is being recompiled. So if we were to apply that to a real project, we would get something like this. This is the command, the magic incantation you need to monitor what bin files are being generated. You just monitor the build directory and grep for everything that's got bin in the file, like grep for bin. And this example project is the one we built in the GraphQL training in the conference, so I found it super convenient to use it. So if I touch like some file here, and I call mixcompile, I'll see all of the files that got recompiled, right? This is like the truth to whether something is being recompiled or not. And at the time of Elixir 1.2, that was all we had. And as you can imagine, if you're trying to find out what gets recompiled for every file in your project, and if your project has 2,000 files, that's like crazy, right? And we started to like write lots of code to parse the output of this and create stuff to reason about that. And by the time that we
did this, we learned about two things. There are two different types of dependencies in Elixir code. There are compile time dependencies and runtime dependencies. And we say that if a module A calls a function from some module B, we say that A has a runtime dependency on B, right? And if B changes, we only need to recompile B, and like every dynamically linked language, we don't need to recompile A, and it's like all the other places that we are accustomed with. But if a module A calls a macro from module B, like uses module B for some metaprogramming, for some code injection, we say that A has a compile time dependency on B, right? That is the difference. And a corollary to that is that if module A has a compile time dependency on module B, this means that A needs to be recompiled every time B is modified. This is what we've shown here, and I'm just giving names to those relationships between modules. Now, how do we find out where those dependencies are? When we first started working on this problem, there were no tooling to help us do that, and we started doing that reverse engineering, touching every file in the project and recompiling stuff, and that was super terrible and painful, and we were super desperate. But after 1 week that we were doing that and pulling our hairs out, I lost my hair because of that, I think, there's this awesome thing came out in Elixir 1.3, the Mixaxe graph, that did exactly what we wanted. And an example to that is, if we call Mixaxe graph, we get this output that describes what are the dependencies between files, between modules. So in this example application, we can see that our application file depends on the repo, depends on the endpoint. The endpoint depends on this web, and it depends as a compile time dependency. All compile time dependencies are labeled as such. And here we have a whole description on how this goes, and you can like read it and understand what are the paths and what are the dependencies between all modules. You don't need to do any fancy thing. And right, we now know where the dependencies are, but what creates those dependencies? After we found that out, well, let's understand why are these edges in this graph exist. And the main 5 situations where dependencies are created nowadays are when a module is imported, required, or used. And that's obvious, because if you're importing a module and you're using a function in that module and that function disappears, you need to recompile your module to find that out and not have some broken code. Like the same applies to require and use. When a struct is referenced with the %module syntax, structs have their keys compile time checked. So if some key changes in a struct, you need to recheck all the uses of that struct to make sure that your code can work. When you implement protocols, protocols are protocols could be a library in Elixir. Only by having macros you could have protocols, so there's nothing special about them. They're just metaprogramming. As such, they create compile time dependencies. When we implement behaviors, behaviors are compile time checked, so there are also compile time dependencies. And the most subtle way dependencies can be created is when an atom that references a module is seen on macro expansion. And that was our greatest discovery when working on that project, that problem. And that yields to transitive runtime dependencies. And what is that? I'm going to show an example of what that is, and then I'm going to show some code to support my point. So we have this relationship between modules, like module 1, module 2, module 0, 1, and 2. Module 0 depends on module 1 on compile time, and module 1 depends on module 2 on runtime. But as we know, we can run arbitrary code when we are doing metaprogramming in Elixir. So the compiler doesn't know if when you're injecting code from module 1 into module 0, if module 1 is calling module 2 anywhere. So if module 2 changes, we need to recompile module 0 to make sure we are not getting the code out of sync. So this means that we have an implicit compile time dependency between module 0 and module 2. And this doesn't appear in the Exraf output. This shows up anywhere, and we found out by reverse engineering the Elixir compiler. And this is really, really important. This is like, if there is something that you need to understand from this talk is this thing, this relationship. And this happens on macro expansion. I'm going to show an example of that. Stop notifications. Let's see. So we have here a module that expands a macro. It requires a macro, and it runs some macro code. And this macro, oops, spoilers. This macro, when expanding the macro, we see this module seen on macro expansion. When the Elixir compiler sees that, it creates a runtime dependency to this. So, and if we look at this, seen on macro expansion, it does this fancy thing, right? There is no metaprogramming here. There is only metaprogramming here, and we are expanding the macro here. So I'm going to show with our iNotify wait trick that this is happening. So I'll compile our project, right? I'll touch the seen on macro expansion module, and when I compile, I see that the expands a macro module is recompiled, even though if we run Exraf, Exraf graph, we don't see the expand. Where is the expands a macro? Yeah, here. We see that it depends on compile time to a macro, but a macro doesn't depend on compile time to seen on macro expansion. So it is not obvious, the relationship between them. It is not obvious, this relationship. And we can say that if module A is modified, every other module with a path to A that contains at least one edge labeled compile will be recompiled. So this is super hard to find out. And by the Exraf output, the Exraf output is generated by a depth-first search. So we can even not see that there. And this can have a profound impact on library code. Many very popular libraries in the Elixir community uses lots of metaprogramming. And this can happen in subtle ways. Like Phoenix scopes, every time we add a scope in a Phoenix router, we are prone to get this kind of relationship. In absinthe resolvers and plugs, and the examples are endless to when this can happen. The most used libraries like Phoenix, Acto, Plug, they are aware of this problem. They were not at the time that we started facing that. We provided feedback, and the authors, the maintainers, did wonders and solved most of the issues. But many libraries that do metaprogramming are not aware of that, and as your project grows, you might be getting this. And if we extrapolate that idea of transitive dependencies with cycles, things start to get real nasty. And let's take this example that is super simple. If you take a real-time, a real-world application, this is super trivial. So let's have in mind this relationship between modules. The arrow means that a module depends on runtime to another module. And imagine now that we have this red arrow of evil. And this means that module 4 depends on compile time on module 0. And because we've seen of the transitive dependencies, this means that since module 4 depends on runtime from module 1, this means that module 0 will depend on compile time to module 1. And that means that module 1 will depend on compile time to module 2. And that means that every other module will have that implicit compile time dependency. If we change the module 6, that is very far from module 0, we'll have to recompile module 3. And if module 3 needs to be recompiled, then all the other modules need to be recompiled. And all the other modules outside of this cycle that depends on any of the modules in this cycle will also need to be recompiled. And that's how you get to 600 files being recompiled when you change a view. If you're not aware of this, you will be like clueless as to what is going on. And one example of these cycles being built is the Absinthe library. I did the GraphQL training 2 days ago. Absinthe is a great library. I really like the idea. And I'm going to show you how you can get into that situation with Absinthe that is heavily metaprogrammed. It is heavily metaprogrammed to our happiness. It is super nice to see and understand and does so heavy lifting for us. But metaprogramming comes at a possible cost. And I'm gonna show another nice feature of Exraf is that we can format that to something we can get into a picture. .png. This is super nice that there is a suggestion when running the command, because I offered this for one. And this is our example application graph. This is impossible to read, and this is a project with 26 modules. So if you have a project with 1,000 modules and you try to get a graphical output of that, you're completely out of luck. It is impossible to reason. And we can see over here that there is an arrow coming back to the endpoint. And the endpoint depends on pretty much all of the other files. So there is a cycle here. And there is the possibility, if you're not careful, to introduce bigger and bigger cycles and have bigger and bigger problems. So the Phoenix Phoenix plug and Ecto did some nice stuff to avoid this problem, and I'm pretty sure that Absinthe also tries to do that. And and making justice to it, I did not dig deeply into that. I did not use Absinthe extensively. This is just an example from the training. And one interesting thing here is that if we change a schema file, we recompile the Phoenix router. And if you recompile the Phoenix router, we end up recompiling all the controllers and all the views. And if you have a big Phoenix project and you're adding Absinthe and a GraphQL API, you might get into the position where if you change a schema file, you need to recompile your whole Phoenix project that should not be super related to schema in another API form, right? So, oh my God, what do I do if I'm afflicted by this problem? What do I do if I'm in the situation where my project is super slow to compile and I'm going crazy? There is a very quick and dirty fix to that Jose himself taught me, and that saved us a lot of time, is the module concat function. And I'm going to show it in that example that we have on this module that sees the other in an expansion. So what we can do is this. We can module concat this. And we notice that we are not using an atom here. We are using a string. And this is converted into a module. And now I'll just call the module here. Oops. Right? I'll get back to the terminal. And I'll run Mixaxe again. Oops. And as we can see, the A macro does not depend on runtime on scene on macro expansion again. So if I touch this file, and I mix compile, only this module gets recompiled. And if this is the module that is creating the cycle, if this is the nasty red arrow of doom, then the cycle will break and you won't have those terrible problems. There is another way to which we can solve this problem, and don't quote me on this. There is a feature in the Elixir compiler called the Lexical tracker. That is the thing that is responsible for building that graph, that is responsible for keeping track of what depends on what. And that thing is completely unmentioned in the documentation. There is only one mention that I could find, is this one-sentence description. The lexical tracker is a field in the macro env struct, and all the description is the PID of the lexical tracker, which is responsible for keeping user info. What that is, you're not supposed to know, actually. But if you disable that while you're doing your macro expansion, you will solve that recompilation problem. But I won't show you how to do this, because I don't want to be quoted on this. But if you're that desperate, there is a way. Now, just to wrap things up, this whole recompilation story is getting better and better. Nowadays, you're much less likely to suffer from this. And this is giving props to the amazing work that the Elixir core team and the library maintainers have been doing. Plugs got the init mode option now. If you're familiar with plug, when you're building a plug pipeline, all of the plugs are compiled together to get maximum performance and that sort of stuff. But that means you get a compile time dependency between all the plug pipeline. And after plug 1.5, the init mode option have been added, so you can, in development mode, don't compile everything. So you won't need to recompile everything on dev, but you will recompile stuff in your prod release to get that maximum performance while not suffering a dev time penalty. And the new Phoenix versions leverage that on the Phoenix new templates. So if you're having this sort of problem, and you probably started your project a long time ago to get to the point to have a huge project, maybe if you just update this init mode, you will solve your issue. Struct dependencies are also now tracked separately. Before Elixir 1.6, every time you used a struct, you get a complete compile time dependency, and that contributed a lot to having cycles and that sort of stuff. Now, we have a different kind of dependency that is a struct dependency that is only triggered if the struct keys themselves change. And the struct keys change much less frequently than the functions in the struct mode, than the functions in the struct mode. So this will trigger recompilation much less often. Type specs don't trigger dependencies anymore since Elixir 1.4. Before that, type specs would create compile time dependencies. And if you went to the encouraged practice of adding type specs and adding documentation to your code, you would be penalized by that. You would create cycles that have absolutely no runtime correspondence, that do not contribute to your code running, but you will get this penalty. And after Elixir 1.4, that was solved. Active associations don't trigger dependencies anymore. Now we have Mixaxe. There's a new option to mix Exraf graph since Elixir 1.6 that I'm going to show right now. That is the Mixaxe graph format stats. And this will do all the heavy work of finding out what are the files, what are the modules that are most dependent and the modules that depend the most. If I had that 2 years ago, I would have solved my problem in some hours instead of some weeks. This is an amazing tool, and thank you, Joseph, for that. And the list goes on and on. As Joseph said in the keynote, the Elixir team has been super helpful in taking developer productivity very seriously, and they tackled these issues super promptly. They were super responsive, and they helped us a lot on that. And now we are much less likely to suffer from this. And to wrap up, avoid metaprogramming if you can. Metaprogramming is awesome, but it has its price. And if you get into a very big project, you might get into that situation that I just described. Avoid dependency cycles at all costs. Please don't do it. This is just, you are one compile time dependency away from losing your sanity. And if everything else fails, use module concat to get your way back to sanity. Use that sparingly. This will pretty much break the compiler. So if you use that and your module actually depends on the other module to inject code, you will start to see very weird scenarios that only a mix clean and mix compile will solve. So if you have this right now, that might be the issue. And thank you. I think we have time for questions.
All right.
You have this slide where you show the cycle and then the red arrow when there's a circular dependency.
Yep.
Could you talk about how the compiling interdependency would work differently if there wasn't a cycle?
OK. Oh, right. How do I do this? Right. So if there wasn't a cycle here, the situation we would have, we don't have any compile time dependencies here. So if we did not have the cycle, we would only recompile module 6, and that's it. But if we had, for example, a compile time, can you see my pointer here? Yeah. OK. So if we had a compile time dependency here, if we change that module, this one wouldn't need to change because there is no path from 3 to 6 that has a compile time tag. The same for 2, the same for 1, but not for 0. So we would recompile module 6 and module 0. Did that make sense? And in a situation where we have this, we would get from recompiling 2 modules to 6 modules, and everything else that depends on any module in that cycle. So this, and in my experience, most of the time, this is what happens. Like you add a dependency, for example, in your authentication plug, you add a dependency to a schema, but the schema depends on the repo, and the repo depends on the endpoint, and that's when the cycle happens. So in my experience, there are very few edges that you need to remove to get out of this situation. And yeah. Did I answer your question? Yeah, thank you. OK.
Well, I'm not sure if I get it, how actually the module concat solves the problem, because when you use it, what are you doing? The module is resolved on runtime. That's why it solves the problem?
Yeah. Let me get to the example here. What happens is, this is, let's have them both here. So this is the very bad and nasty solution. And this is the previous code. Fancy thing. Right? What happens, the dependency graph is built when the compiler is in its lexical phase. So the compiler will see this atom here, and will put it into some data structure saying, okay, this module have seen this atom, and if there is a module referenced by that atom, then the tracker creates that dependency. And that happens before executing code and before doing the actual macro expansion. When we do this, the lexical tracker does not see an atom, so it does not add that entry to the data structure, so it cannot create that dependency. The problem with that is if I actually did something is this, and I didn't quote like something here, like I unquote the block, and I like unquote something here, this would break bad because I'm using the logic in that module to generate code in this module. The compiler is very conservative because it tries to be correct at all times, but sometimes it's overzealous. Is that a word? It is overzealous and creates situations that hurt us. So this way we can trick it, but we need to be very responsible doing that. Did I answer you? Okay, thank you. More questions? Yeah, another one.
If you load your module names like out of config, like you dependency inject, does that count as seeing during compilation?
You mean like when starting the application?
Right.
Yeah. If you're getting a runtime config, then that won't happen because the code is already compiled and we already know all the dependencies, so we won't have this problem. The issue is if we are doing any kind of metaprogramming and reading from application getenv, then we would have the very same problem. If we are using, the thing is, executing and compiling Elixir code are indistinguishable. You can't distinguish these two phases. When you're running Elixir code, you're already compiling Elixir code. So some might say that the Elixir compiler is not very well behaved, but it is necessary to get us all the joy of having metaprogramming. And in a situation where we get something dynamically at compile time, and we persist that as code, if we don't track the dependencies well, we will get into a situation that nothing makes any sense, because you read the code, and one situation where this happens is when you're reading a file, for example, when the Elixir Unicode implementation reads a Unicode file with all the symbols and generate pattern matchings for that. And there is a special attribute that I didn't show. I can't really recall the name. That it's like when you have a make file and you add a dependency to a resource file, that if that file changes, compile this again, and that could be a text file or whatever. If you forget that, then if you change that, you won't get the changes in the compiled module, and you won't get everything worse until you do a mix clean and mix compile again. So, yeah.
We have run out of time for
Okay.
questions. You guys can catch Renan in the hallway, and let's give him a round of applause.
Right.